I often get asked for tech podcast recommendations. So have you heard of We Got Your Mac? It's a new podcast from a global tech solutions provider called SHI. And essentially every 2 weeks, it explores the benefits and the challenges of Apple Mac's platform across the enterprise. So for everyone that asks me for recommendations, and especially if you're looking for advice on implementing Mac in the enterprise, check out We Got Your Mac wherever you get your podcasts, or simply go to wegotyourmac.com and you'll get access to all of the episodes, plus lots of resources to help you decide too. Hello everyone, welcome back. I'm Neil C. Hughes, your host for the Tech Talks Daily Podcast, where every day we explore the intersection of technology, business, our lives, and even world. And today I've got a very special guest joining me. His name is Kenneth White, and he's from MongoDB, a company that has been a game changer in the database world for well over a decade now. And in this episode today, I want to take a deep dive into MongoDB's latest innovation, Queryable Encryption, and also discuss its impact on the world of data security, privacy, and beyond. But enough from me. Buckle up and hold on tight as I beam your ears all the way stateside, where you can join me and Kenneth in a conversation about all this and much more. Please tell everyone listening a little about who you are, what you do.
So I'm Ken White. I'm a security principal with Mongo. Been with the company about 6 years. My focus is on platform security. So all things security, all things crypto, work both directly with developers as well as senior leadership. So, and work across, all the different development communities. So all the major languages and folks that work in those. These days, I've been focusing a lot on end-to-end encryption product that we launched into preview about a year ago, and it went to GA this summer called Queryable Encryption. So looking forward to getting into that with you. But yeah, so I guess I'm one of the public faces of MongoDB in terms of security.
Well, it's a huge pleasure to have you on the podcast today. And of course, MongoDB has evolved so much since its inception over a decade ago. So I'm curious, if you look back, how would you describe the company today?
Yeah, that's a great point. I mean, we've always been developer focused. We've always been, popular with startups. I think one thing that we're kind of misunderstood these days is just how much we're sort of deeply in the enterprise space. So for example, our systems and technology are powering some of the biggest credit card payment systems in the world, some of the biggest bond clearinghouses, things like capital markets, treasury platforms, and currency exchanges. These are what we refer to as high value target, workloads. So really critical, financially critical workloads, but also in the healthcare space, lots of things going on there, critical infrastructure, telecom, consumer electronics. So we've kind of got our reach quite wide, across so many different vertical markets. But yeah, I mean, I think a lot of people who kind of may have been introduced to or had some experience with Mongo 10 years ago, they have a very different view than where we've evolved today. We're kind of deeply in some of the core systems at some of the biggest, investment retail banks in the world. So yeah, it's definitely massive evolution over the last, 10 years or so.
And before you came on the podcast today, I was reading that MongoDB announced earlier this year its first of its kind Queryable Encryption. And I'd love to dive into that with you. And we will have a mixture of business leaders, techies, and developers listening. So just so we reach everybody here and make sure no one's left behind, can you expand on what it is and also the thinking behind it too?
Sure. So Queryable Encryption is our third generation encryption platform. We very early on launched a type of whole database encryption called the Wired Tiger encrypted storage engine. And the idea there is that if you've got critical workloads running in a data center or something where, it's kind of on-premise or self-managed or, that you're running yourself in the cloud, that, you wanted an extra level of protection beyond just sort of the standard kind of, authorization and access controls and things that are in place now, particularly for things like media, either a disk that was, retired or repurposed or something like that, or in the cloud context where you're constantly, deploying new virtual machines and then you release those back into the fleet. And so, some other cloud customer comes along and you just want to make extra, effort, extra sure that you're not leaving any kind of sensitive data. Our next sort of evolution was in the end-to-end encryption space. So the idea there is that even if someone had, really high privileges like a database administrator, or a system admin, or even someone at a cloud provider, or one of us on the service side, we run our own massive cloud service hosting MongoDB. If there was a mistake or misconfiguration, how could we still kind of, reduce our risk as a customer, as a developer? And so we released that. It was really, popular. We saw lots of adoption across all different kind of, different verticals. Queryable Encryption takes that a step further. So one of the teams that we worked with, actually, I should take a step back. So when we started the end-to-end encryption project called client-side encryption, we sort of started with the premise, which is, we're pretty good at building distributed databases, but we're not cryptographers. And we've seen enough in the security space to know that, really tiny mistakes, really subtle coding errors or just design decisions could potentially have, devastating effects to basically kind of undermine the whole point of encryption, where, there's, I won't say fragile, but you really need sort of deep expertise, to sort of design and vet these systems. And so with that sort of in mind, we worked with a couple of different outside groups, people who literally, they make their living, breaking encrypted systems, breaking databases, and then also designing new types of encryption or sort of analyzing things that are out there. Anyway, one of the groups that we worked with was this team by Seni Kamara and Tariq Moataz at Brown University in their encrypted systems lab. So that was a great collaboration. We learned so much. They were just, tremendously, useful in working with us. They eventually sort of spun off a little commercial startup for some of their kind of R&D work that they'd done sort of independent of Brown. And we had a discussion a few years ago, just sort of catching up, sort of checking in with each other. And it became clear when they were describing what they worked on that they had a major breakthrough in their tech. And, sort of fast forward, what it meant was that there was a type of encryption technology where on completely encrypted data, you could do things like search for just part of a string or search for, date of birth or something that was where the values were encrypted, or search for like, the final few letters or final few numbers of the social security number, something like that. Really being able to do expressive searches on completely encrypted data where the database didn't learn anything about the encrypted data. And so eventually that led to us doing an acquisition of their spinoff. And now they joined Mongo. And so today we've got a full-blown R&D advanced cryptography research group center with a number of academic PhDs, visiting student interns, visiting scientists. So it's a real, serious powerhouse in the encrypted search space. And so Queryable Encryption is sort of the first, the first sort of result of that, of that process and that acquisition. So we're super excited about it. But yeah, that's what we rolled out. And so it allows developers without having any background in crypto to put, really sort of leading edge kind of technology in place to, protect confidentiality of really sensitive data. And so that's what Queryable Encryption is. It works on all of our platforms, every major programming language, so Go, Java, Python, Node.js, PHP, C#, the whole thing, and on every platform. So whether it's mobile, Intel x86, the new ARM processors, the specific ARM processors that, different cloud providers have, and on every operating system under the sun. So in a nutshell, it allows, business people and project leaders to choose a technology that really reduces the risk of super sensitive data. And so, happy to get more into kind of some of the threats or things that customers are concerned about or that developers work on. But that, in a nutshell, that's it. It's a way to completely encrypt data, but also maintain the ability to do expressive searches on fully encrypted data. And it's the only one in the industry. So we're super pumped about it.
So if we have a business leader listening who, let's say their organization is facing a variety of strict data privacy requirements, just to bring to life everything we've just talked about there, how will this help them?
Right. So a lot of times this is an area where both some of the regulators, and some of the compliance frameworks have an imperfect understanding of what different types of encryption can do. And so, we've had encryption at rest, the idea of, when you save something to disk, having it encrypted for, I don't know, 15 plus years. And there's a notion in some spaces, when people are thinking about things like GDPR or the thing about, complying with the credit card processing folks, the PCI and things like that, that just being able to encrypt a disk is enough. And so when people get a little more into it, they realize that no, that doesn't really work the same way in a database as it does a browser, right? When you're on a web browser and you go to, you're looking up a news article or something on the Washington Post, you want to make sure that, if you're sending logon information or to your bank or whatever, that the data that you're sending is not visible, over the network. And so we've got things that handle that pretty well. And that's, mature kind of table stakes technology with HTTPS and TLS. As I mentioned, disk encryption has been around forever. What people rarely think about is that in this context of databases, the disks aren't sitting there, right? They're not sitting on a shelf with the database turned off. The most useful data we've got is on active running databases. And so no one really talks much about data that's in use, on a server, right? So when any database is up and running, if it's working on sensitive data, who's protecting it from the administrators, the DBAs, or, like a DBA, for example, by design of their job, they need to do patching and updates and security, things like that. But what if they're maintaining, say, an HR database, right? Do they really need to understand or know people's bank account information or their health insurance claims or their social security or tax ID numbers, things like this? And the answer is often no, but historically, there's not a really good way to be able to give someone really powerful privileges to administer, but also not sort of to expose them. And the same with the service operator, right? I mean, I think a lot of things, when we think about security in the cloud context, we don't really think too often about, there's a bunch of really high privileged people that had full visibility into the hypervisors, the virtual machines, the underlying infrastructure. Now, we have all kinds of things in place. We have all kinds of training. We have all kinds of, controls in place that say, don't snoop on customer data. Don't look at places you shouldn't see. And if you do, maybe you'll get in trouble, or maybe you get fired, or maybe you'll go to prison. And those are, those are reasonable things to have, but they're not technical controls. They don't stop someone from actually doing it who has that kind of visibility, right? So in some contexts, I think sometimes in security, we get a little dramatic or whatever. But there really are kind of, advanced scenarios where, when you're talking about these systems that are processing, tens or hundreds of $1 million a day and, in funds flowing through, you really do have to think about insider attacks. You really do have to think about, blackmail or, something even more mundane, right? Companies all the time are involved in litigation. And sometimes those things require what's called a litigation hold or a seizure, right? And companies want to be able to know if their data has been taken. And so encryption is one way to sort of have some additional controls around that. And also just frankly, the stakes at some of these workloads that I'm describing, these can be, really well-resourced attackers, maybe, nation state level resourced attackers. And that's not a James Bond kind of fiction thing. This is, when you really are trying to protect the data, at a major currency exchange or major foreign markets or, capital markets, that you do have to kind of game some of these scenarios out. And so it's we're not claiming it's some kind of silver bullet or it's, it's something to make, any system hack proof by any means. But what it does is it makes attacks complicated, harder, noisier, and, and slower. And that's our goal, right? Is to reduce risk, to make an attacker's life, harder while we're trying to protect our data and make it useful for developers that are building these systems.
So queryable encryption, it reduces data exposure by encrypting data during transport. And of course, data security is undoubtedly a top priority for most businesses right now. And for any curious techies listening, wanting to maybe take a look under the hood or a peek behind the curtain, are you able to provide those people listening with maybe an overview of how you've been able to achieve this at MongoDB?
Yeah, absolutely. And then also I'd say we can share some links to really deep dive technical papers that go both into the kind of the formal security definitions and, the architecture as well as, the specific threat models. And if, one is mathematically inclined, if you want to get into the proofs and, the math behind the core primitives, we can, or the constructions rather, we can do that as well. But in a nutshell, what happens is let's take an example of a mobile application, right? Where you've got millions of people using a mobile device. Those connect to a web service that's, an internet-facing web service. And the idea is that from the point of that web service all the way through the system, all the different, servers that are sitting on it, any kind of logging, any kind of temporary files, any other kind of analytic systems, whatever, the data will remain encrypted, basically from the point of the application all the way back to the application. So if you think about something like, one of the secure messengers like Signal or WhatsApp, I think we have a little bit of intuition of that, right? If I'm talking to you over, a text conversation, I want to be able to read it. I want you to be able to read it, but I don't want anyone else in between. If you're not on your phone and that message has to sit on a server for a while before you log on or check your messages, you want to make sure that the infrastructure, the actual hardware isn't seeing the data, and the operators, that hardware is not seeing the data. So how it works is all of our drivers now have built in a crypto library that looks at the data, looks at, let's say you want to do a search on, find all records with users whose social security number is, 123 or et cetera. You have to do a couple things in order to pull this off. One is you've got to encrypt the social security number when you saved it in the first place, but you also actually need to encrypt the query. So if the database doesn't know what the filter is, right? If I didn't know that, if I'm a database operator or administrator, it's not just that your documents or your records have to be encrypted. The individual, like if this were a relational system, like the cells or the rows have to be protected. But also, I can't even know what queries you're running, right? Because the query themselves would be sensitive. If in your filter it's, everyone with, this medical diagnosis or this, this prognosis or this financial value and an account balance, you have to protect that as well. So what the software does automatically, once you've set this thing up, sort of initially, it looks at the data that's about to go to the database and says, okay, well, field 1, 2, and 3 are supposed to be encrypted. So I'm going to convert those into encrypted values. Then I'm going to send some special search tokens. These are cryptographically defined tokens. I'm going to send that off to the server. So the server says, okay, well, I just got an encrypted document. I don't know what data it's sitting on, but I've also got this other special token. Now I can't search encrypted data natively, but what I can do is take this token and build up kind of a dictionary where I can derive some other information from that. I'm still blind to what information that is, but the next time a query comes in, I'm going to take that information, I'm going to use these tokens and sort of walk a tree. I have no idea why I'm walking that tree. I don't know what the relationship is between documents that hit. All I know is that at the end of that, maybe I hit 3, maybe I hit 12, maybe I hit 2,000 documents. I'm going to return these encrypted files back to you, or encrypted documents back to you. I don't know why, and I don't know what you were asking for. So that, in a nutshell, that's what happens. And then once they get back to the client, to the driver, to the MongoDB driver, it automatically decrypts them and passes it to the developer. So from the developer's perspective, they said, database 3, people find social security number 123. And at the end of that, they get 3 encrypted documents back that looks just like what they would expect. All the complicated stuff kind of happened behind the scenes. But in a nutshell, that's the basic flow.
Love that. And I'm curious, though, what were some of the biggest challenges that you and your team had to overcome before launching this? Because I suspect behind the scenes there was a lot going on there, right?
Yeah, I mean, one of the things that I've described before is that, when we started the project, we assumed that 90% of our engineering was going to be on the cryptography. But in fact, that turned out not to be the case. Where a ton of the engineering happened was making it so that developers didn't have to get into, dealing with keys and, understanding all the different, I don't know if you've ever looked at like a, web server configuration, but there's one of the first choices you make when you set up even a basic web server is, well, here's a menu of 27 different types of encryption techniques that you can use. And most developers sort of throw their hands up and they're like, I don't know. And they get on, they hit the search engines or Stack Overflow and, hope they get the right answer. And so what we did is we made it really opinionated so that you don't have to make those choices. You don't have to think about cipher suites. You don't have to think about, AES versus, some other technique or a different kind of HMAC or different kinds of Diffie-Hellman or key exchangers, things like that. You don't have to deal with any of that. And so most of the heavy lifting was on the query side, was to make it so that the way that developers are used to writing an application, they'll continue to be able to do with the benefit of, of this encrypted protection. Now, the other thing too, which is this isn't really new technology. That's the ironic thing. This particular technique is based on a type of cryptography called structured encryption. And it's actually been around for like 15 plus years. There's actually the entire field of encrypted search was originated by Sandy Kamara, who's now leading our crypto R&D team. But the problem with a lot of the academic work that already existed, if you read the titles of the papers and the abstract, you could come away thinking, wow, we've already got this sorted out. But then if you dig deeper, it's not so simple, right? So a lot of the academic papers will do something like this. Let's assume I have one laptop and it talks to one server, and I'm gonna do this process, and then I'm gonna get, the data back. And you start digging around a little deeper, and you're like, yeah, but in real world systems, we're dealing with the internet, right? We're dealing with flaky mobile connections. We're dealing with unreliable and jittery, networks. Connections go up and down. Clients die all the time for no reason. And by the way, we're never talking about one database. In real systems that are of any consequence, these are distributed systems, right? They've got, 2 or 3 or hundreds of individual, cluster members behind the scenes. That's how real databases work for banks, insurance companies, and, these big high traffic sites. And there was no real choice in the academic world. It's just not considered. It was very naive. And then so some solutions were like, well, okay, that's fine. You can have multiple clients. You can have lots of different, users of this database, but they'll have to create a special kind of encrypted cache, and you'll have to design that. And then you have to make sure that stays synchronized between everyone who's ever going to use your database. And it's like, okay, it's hard enough to write just like a basic Python application that does, meet sort of a baseline level of security. To be able to, also do a distributed cache on encrypted, that's just not realistic. And so taking some of these kind of naive approaches that were not really designed for distributed systems, that assume that developers were going to be doing a whole lot more heavy lifting than they really do, that was where a lot of the challenge was. And that's where I think it's going to be hard when other organizations or other groups try to, replicate this technology, because the core piece is there, but actually getting it to operationalize and making it fast, that's the other thing too. That one of the major goals in the system was high speed, because a lot of the encrypted systems, they work great with like a dozen records or 100, but you get to 10,000 or 100,000 or much less 1 million records, they just break down completely. They grow linearly, which is to say every new record that you add, it gets progressively slower. The structured encryption techniques that we've used that the crypto team built, they do what's called sublinear search. So it doesn't matter whether you're searching 1 million records, 100 million, or 300 million. It's not, you don't grow slower linearly as a function of the number of records. And so that performance work took a long time. I think we spent probably 5.5 months just getting the performance in a space that we, in a good place that we needed to. So now when you issue a query, it's, 2-3 milliseconds, which is, well within the range of, modern web app kind of, design requirements.
And of course, we now are officially only weeks away from life in 2024. So what will be MongoDB's priorities in the new year? I appreciate you're probably locked down and can't share too much, but is there anything you can share about what you'll be focusing on next year?
Well, I can highlight some things that we've either hinted at or we've already sort of discussed. So we're going deep on AI. Our new vector search that's in preview is just iterating like mad. We sort of realized, I don't know, about 2 years ago that an awful lot of AI companies, generative AI in particular, were using Mongo for kind of sort of some of the basic heavy lifting, right? Because one of the things that people don't talk too much about with AI is all the needs for training and tagging and all kind of all this sort of, I won't say grunt work, but it's a ton of pre-processing and things that you sort of got to have before you can get to kind of the more, high-end esoteric stuff. And so it turns out that a lot of, hundreds of AI companies were actually already backing their systems on MongoDB. And so, yeah, we're making rapid advances with vector search. That's going to be huge. We're doing lots of enhancements to Atlas Search, which is a sort of a full text, really high speed search that marries, the traditional document database. And then obviously security. We're iterating on so many different, next generation features and capabilities. But let's just put it this way. We have a full-time, sizable crypto team that, their whole mission is working on privacy preserving technology. So, we'll be looking at things like differential privacy. We'll be looking at things like multi-party computation, secure, shared, private workload computation, these sorts of things. But yes, I'd say security, AI, advanced search, those are probably among our top three that we're really hammering on right now.
And before you came on the podcast today, I was looking on your Twitter feed. Great seeing the dark mode is coming soon. Your community was looking forward to that, I could see. And I do suspect there's going to be a few passionate members of your community listening. So before we go, is there anything else you wanted to cover?
Yeah, just to say that if any of this sounds interesting, just, fire up a search engine and search for MongoDB Queryable Encryption. We've got tons of tutorials. If you just want like a 5-minute kind of copy paste, hello world level, just to sort of get a sense of it in every language that, that's out there, we walk through it. There's, all kinds of example code, lots of docs, lots of good things. So this is an exciting part of the company. We're super pumped about it. And, I'd love for developers to kick the tires, take a look, see what they think. But as I mentioned too, we'll share some more links with you that you can share with the audience for the technical white papers and some of the deeper, the deeper analysis and artifacts that we've got.
Well, I'm currently fighting the urge not to give you my best Steve Ballmer impression saying developers, but if you could send me those links for any techies wanting to look what's under the hood, I'll make sure they're added to the show notes. But more than anything, just a huge thank you for taking the time to sit down with me and share your story and the great work you're doing at MongoDB. Thanks for joining me today.
Thanks so much. I appreciate it, Neil.
So a big thank you to Ken for sharing such insightful perspectives on MongoDB's advancements, especially in the realm of queryable encryption. And to everyone listening, whether you are a business leader grappling with data privacy challenges or a techie curious about the inner workings of MongoDB's cutting-edge technology, please, if there's anything you want to add to this conversation, if you've got a question to ask, if you'd like to join me on an episode, whatever it is, email me, techblogwriter@outlook.com, Twitter, LinkedIn, Instagram, just @NeilC.Hughes. And don't forget to check out links that Ken mentioned for a deeper dive into MongoDB's technical world. But that's it for today. So until next time, remember, love your developers, keep pushing the boundaries of innovation, and I'll speak with you all bright and early tomorrow.